Today we're going to be solving exponential and logarithmic equations. In method 1, you will solve the exponent equations by getting the same bases on each side of the equal sign. With logarithms, you would try to get the same logarithm with the same base on each side of the equal sign. This is called the one-to-one property. Now here are some examples using exponents. In this first example, we see the base of 5. 5 is raised to the 3x minus 6 exponent. And then we see 125. If you think about 125, it is really 5 to the third power, because 5 times 5 times 5 is 125. So we could rewrite 125 as 5 exponent 3. Now we have a one-to-one pattern. So we cancel the 5's and you just drop down the 3x minus 6 equals 3 and solve. So I would add 6 to both sides of the equals. 3x equals 9, divide by 3, x equals 3. That is the final solution. On the other side, example B, we see an 8 and a 4 as the bases. And you cannot rewrite 8 as a base of 4 or vice versa. But both of those numbers are divisible by 2. 4 is actually 2 squared, 2 times 2. 8 is actually 2 to the third, 2 times 2 times 2. So we could rewrite this as 2 to the third with an additional exponent, x plus 2, equals 2 squared, that takes the place of the 4, with the additional exponent, x minus 3. Again, now we have a one-to-oneness with the bases of 2. So cancel the 2 and just bring down 3, parentheses, x plus 2 equals 2, parentheses, x minus 3, and solve. I'll solve by using the distributive property, and I get 3x plus 6 and 2x minus 6. I can now subtract 6 on both sides of this equation, and I can go back and subtract 2x on both sides. So x would equal negative 12. That is my solution. When it comes to a logarithm, you want to log on both sides of the equals with the same base. Here we have log base 3 on both sides. So we can drop that log base 3 because they're both equal. It's that one-to-oneness. So I would just bring down the x plus 2 and the 2x minus 11 and set those equal to each other. I could subtract 2 on both sides of the equation. I could, that was a positive 2x. I could now subtract 2x on both sides of the equation. And then just divide by negative 1 to get x equals 13. Now you always want to make sure that your answer, your solution, when you substitute it back into the logarithm, would give you something positive. Because if you started with a positive base 3 log, you would have ended up with a positive answer. Now method 2 is a little different. Instead of matching up the bases on each side of the equals, you will simply rewrite the original problem using the definition of logarithm. In this first example, it's written in exponential notation. But what we want to do is rewrite it as a log. So I would put log, the base is 5, the number is 134, and that's equal to the exponent x. Well, this technically is the answer. Now you could put that in your calculator as log 134 divided by log 5, and you could even get a decimal answer there. On this next equation, we'll do the same thing. It's written in exponential form. So I will rewrite as a logarithm. So I put log, the base is 10, the number is 8,000, and that's equal to x, which is the exponent. Now if you recall, log base 10 is a common log, and that is the log key on your calculator. So this is really just log 8,000. Again, you could type that in your calculator and get a decimal answer if it is requested. Now in this one, we will rewrite the logarithm as an exponent. So we want to rewrite this in exponent form. So by definition, we know that the base in that log is the 2. The exponent is the 3, and that is equal to the x minus 4. Now 2 to the third is 8. When we multiply that out, we will then add 4 to both sides. X equals 12. And again, that positive 12 is a permissible answer. In this log, we must first use our properties of logs before we can solve it. Notice that this would be 2 logs that are added together. So that means I could rewrite this using my property of logs, that this would be log of x times x minus 3. Now if I rewrite this in exponent form, the base is 10. It's an understood 10 because there was no base number given there. That is a common log. So it's 10 exponent 1 equals x times x minus 3. And we'll solve. So I have 10 equals x squared minus 3x. Move that 10 over by subtracting. So I have x squared minus 3x minus 10. This one would then factor. We had used the factor method, x minus 5, x plus 2. And you see that you get 2 answers. X equals positive 5 and x equals negative 2. Now remember, especially with these negative answers, a negative answer when substituted back into the log should not give you a negative result, because if you start with a positive base 10, your log should give you a positive result. So in particular, if I check the answer of the negative 2, you see how that's going to look like this? Log of a negative 2 plus log of a negative 2 minus 3. That is impossible. So we would say that the negative 2 does not check. The only solution is the 5. And this is how you go about solving both exponential and logarithmic equations.